This is Qt 5 Design Patterns Section 9. This is structural patterns. Again, these are industry standards. It's not specific to Qt. You can take what you learn and apply it to other languages and frameworks. We're going to talk about things like the adapter, which manages an interface of different classes, a bridge, which separates an object's interface from its implementation, a composite, which is, well, pretty self-explanatory. It's a structure that is other objects combined together, along with a decorator. It adds responsibilities to an object dynamically, and a facade, which is a single class that represents an entire subsystem, and the flyweight, a fine-grained instance used for efficient sharing. Diving into structural patterns. So where creational patterns focused on creating objects, we are now focused on the structure of an application, or how it actually functions. The adapter design pattern is an old pattern, but it's one that's very useful and you're going to use over and over again. Reading it, it's very vague. Convert the interface of a class into another interface client expects. Adapter lets classes work together that couldn't otherwise because of incompatible interfaces. What? So there's a billion different ways of doing this, but basically you wrap an existence of the class in a new interface, and you can try and mix and match if you want, but really it's very loosely dependent on your system and your requirements. So looking at a real-world example here, we've got a file logger, does exactly what it says it does, just opens log.txt, writes to it. Customer comes to us and says, okay, we have this file logger and it works as expected. Let's go ahead and run this. Logged, hello from legacy system. And now we want to write the date time in front of this. Oh, that is super frustrating. Okay. Well, we can do it a different way. We can do it the snazzy way. We can, however you want to do it. And they go, nope. You need to reuse this old legacy system because there's some special magic in this code that we can't mess around with because Bob no longer works here. That's usually the story you get. So we're going to go into create a new class, make a log adapter, and next. Because this file logger already exists and we cannot modify it, we can't really work with an interface. But what we can do is wrap the object. So we're going to include the file logger. There's tons and tons of ways of doing this. For example, you could actually do this right here in the constructor if you really felt like it. So we're going to say private, and let's go ahead and go file logger. And from here, we're going to say mlogger. Actually, let's make that a pointer, get around that whole copy issue. And we could do it in the constructor. I'm just going to do a getter and setter. Very, very simple. And then from here, I'm literally going to take this shebang. And I think they wanted, if we look at the customer requirements, they wanted the date and time. So I'm going to say Q, date time, flip into our right here. And then we should, just because I know someone out there is going to say it, we should do some sort of testing here. So Q, debug, got a little sidetracked, right back where we were, Q info. And please set the logger. So if there's no logger, then we're going to say please set the logger. And we should actually return out of here. Pretty simple. You've probably done that a billion times. Then from here, I'm going to say QString. And let's call this current. Equal Q date time, current date time, toString. Put it in whatever format you want it. And then we're going to just simply say QString new message doesn't really matter, to be brutally honest with you, is going to be current plus our original message. From here, you're probably going, oh, I see what he's doing. Yeah, it's very, very straightforward. Very, very simple. This is one of the older design patterns out there. It's also one of the most straightforward and easy to understand. Really, when you see adapter, think wrapping. You're just simply going to wrap around this object. You can do a whole bunch of fancy things if you really, really want to, but there's really no need. I'm going to say include, and let's say log adapter. And from here, we can actually just comment out the old code and say log adapter. Let's just say adapter. Let's go ahead and set the logger. And then, of course, we'll have the adapter do the work for us. Save and run, see what this looks like. Sure enough, there's our date and time, and hello, new system. Simple, easy to use, pretty straightforward. Unfortunately, it also has a very loose interpretation. There's very few hard, concrete rules about this, and tons and tons and tons of examples. So you're going to see this in various forms out in the wild. Let's go ahead and talk about the bridge design pattern. Now, this pattern is a little bit different than the adapter pattern. They're very similar, but they're a little bit different. Now, what's the main difference? The adapter pattern is done after the classes are created, where the bridge pattern, what we're talking about here, is done before the original classes are created. So this really becomes a design choice. So what are we really talking about? Like I said, very, very similar to the adapter pattern, but however, the bridge pattern, you have two different objects, but you want them to act in a similar fashion. This can be done thousands of different ways. I'm just going to say it. You can do this through inheritance, through interfaces, through casting objects, whatever you wanted to do. But really, the bridge pattern is meant to take two different objects and make them act very similar. Let's take a look here. All right, if you want the official description, it's a decouple and abstraction from its implementation so the two can vary independently. Note, interfaces make this simple. I have to keep pounding that into people. All right, so we're going to right click, add new. Let's make a header. Let's call this iLogger. And you notice how I'm starting from scratch. I'm not saying, hey, I've got a bunch of code already made. Just trying to really drill in the fact that you would do this before you write any code. And just to save some time, there will be some copy and paste going on here. So we've got our interface, nice and simple. If we wanted to put a deconstructor in here, we could. All right, so really all this thing does is just writes out a QString. This is why I use interfaces, because the interface now acts as the bridge. Very, very simple. Let's go ahead and put that deconstructor in there, just because it's going to annoy me if it's not in there. There we go. And let's say virtual. All right, now we've got our main file, and we want to do something super simple. Let's just say interfaces iLogger, and we want to do something like this. Void log. And we're just going to say for int I equals 0, I is less than, let's say 5. Not really doing anything super snazzy here. And then we can just say logger write, and then we can write out the item. Again, this code is very simplistic. We're just showing how you would make a bridge. Now, we have the bridge, this iLogger interface, but we don't have any classes that actually use it. So that's why I use the interface, because it doesn't matter now what type of class I really want to make. It's just dead simple. So I can say add new, and let's add a class. Let's call this simple logger. And then we can just fly right through this very, very quickly. I'm going to say public iLogger. Got a little keyboard happy there. There we go. Make sure we are inserting that. And I mean, as you can see, this just becomes straightforward, dead simple. Gonna just copy and paste our code. Whatever we wanted simple logger to do, in this case, we're just going to write out a log file, and we're just going to take it as is, but put a return line feed and then just pump it out. Now, we could actually go in here and use it this way. So let's say we've got simple logger. That double space is going to bug me. And then we could call our function directly. Very, very simple. Now, someone comes in and says, well, simple logger is too simple. Let's go ahead and make an advanced logger. Well, again, because we're using interfaces, this just becomes dead simple. And this is why I love interfaces so much. Let's go ahead and do a little copy and paste here, just to save a bit of typing. Insert a virtual function. Again, nothing super complex about this. And then we can go ahead and just implement it. Just going to paste the code in there rather than type it in all out. Again, really all this does is takes a log file. Notice how I have the same log. We can change this if we really felt like it, because these are two different classes and it's not going to conflict. And our advanced logger does some advanced stuff, like shockingly puts the date timestamp in there and then pumps out the advanced log. Very simple, very easy to understand. And this is why the bridge pattern is actually really, really popular. Now we've got our advanced logger, and as you would have guessed, it is super simple just to switch this out. So I can say advanced logger, and let's call this a log. And now if we didn't want to use the simple logger, very simple, very easy to just switch that out. Why? Because we're using interfaces. The main takeaway from this is the bridge design pattern is really, really meant to be before you start writing the classes, where the adapter we covered in the previous video is after. So one thing you should always ask yourself when you start to design your classes is, how are these going to interconnect? At what point do I need to make sure I future-proof my application? And usually when I get to a point where I'm going to do some sort of I/O, for example, logging, that's when I stop and say, what type of I/O am I going to want to do in the future? And that's when I'll actually make and implement an interface. Continuing on our journey, we're going to talk about the composite design pattern. It's one of the older traditional design patterns, and put simply, it's an object made up of other objects. Sounds simple, but there's a billion different ways to implement this. There's really no set in stone kind of rule set that you need to follow. For example, you can have a composite object that is a tree structure. You can have recursive composition. You can say is a one-to-many, has a, or a is a hierarchy. Really, however you wanted to do it. And there's some really great examples out on sourcemaking.com. We, of course, are going to do our own way, which I'm going to actually show two different ways of doing this. So first way, let's say you have a school, it's just a basic Q object, a student, and a teacher. Nothing fancy about these, they're just blank Q objects. Typically, you'll get like an interview question where they say, make a composite design that has a school, the school has teacher, and the teachers has students. So you're going to go in here and you're going to make some class, doesn't really matter what it is. And then we're going to just include some stuff. I'm going to include those three real quick. Then I'm going to say private. And we're going to make some variables here. And then you're going to find very quickly, you're going to start fighting with things, and I'll show you what I mean. So now we got to go student. All right, so now we have our school, our teacher, and student. Real quickly, we're going to right click. We're going to make a getter and setter for each one. What did we just do here? What is the major issue we're going to run into? If you guess the copy constructor, you would be absolutely right. So let's save this. We've got our object. It's got other objects in it. Let's go ahead and build it. Let's see what happens. And we get a ton of, you guessed it. Very, very frustrating. So now suddenly we've got to start playing around with pointers and all that stuff. Not super hard to fix these, but then somebody comes in and says, but what if you want more than one teacher? And what if each teacher has more than one student? Oh boy, now you see how this can get super frustrating, because now you got to have a queue list and on and on and on. So then you'll have something that says teachers, and it's a queue list of pointers to teachers, and then each one on and on for students. There's a better way, in my opinion. So we're going to just completely kill that. And I'm actually going to just delete this thing. I'm going to remove this prototype altogether. Once that's out, we're going to give this a good build just to get rid of all those little gremlins lurking in our code. There we go. What we're going to do is we are going to talk about, you guessed it, a parent-child hierarchy. QObject has this baked right into it. So let's make a function. We're going to call it populate school, because the school is going to be our parent object here. So I'm going to say school. Let's call this school. Very descriptive variable names, I know. And let's go ahead and say, I'm going to actually use a pointer. Qt tends to favor pointers, so I try to work with those when I'm in tutorial land here. So all this function is going to do is take that root object, our school, and populate it. So I'm going to say for int t stands for teachers equals 0, and let's say we want 5 teachers. We can take this same little guy here, copy it, paste it, change this to S for students. And let's say we want 20 students per teacher. Why not? And then it becomes very simple, very easy to understand what we're doing here. So we're going to just say teacher. Maybe, if I could spell teacher, maybe I need to go back to school. Wow, I'm really blowing that one. All right, there we go. Equal new, and whenever you see the new keyword, you should instantly go, uh-oh, we're heading into memory land, and you're absolutely right. So we're going to say teacher. Now we're going to actually set the parent here. Why? Because I don't want to have to mess around with memory. So we're going to use Qt's built-in parent-child hierarchy. We're going to set this new teacher as a child of the school. And then I'm going to say, I just cannot seem to spell teacher today. Wow, my teachers would be very disappointed in me. I'm going to say set object name. And we're going to say QString number, and then whatever T is. So we're not going to give them super descriptive names like Bob, Mary, Sally. We're just going to say teacher number, whatever. Then we can just take this same thing, copy this, paste it, and I'm going to say student. Student is going to be a child of, you guessed it, the teacher. So what are we really doing here? We're building a hierarchy here. We're building an object tree. So just to recap here, we have our school. Inside of the school, we're going to put some teachers. Inside of the teachers, that's kind of morbid when I think about it, we're going to put the students. So now we have a nice tree. Notice how we're not doing anything like school dot append or school children append. There isn't even append if you try it. It's just not there. Let's try insert. Nope, not there either. So going to comment this out. Just want to put this here. Where is this actually happening? Well, you guessed it right here. When we set the object and we say, hey, make this the parent automatically knows, add that to the children in there. So we don't have to mess around with adding it. It's just automatic. Really, really cool how that works. So now we can set the parent-child relationship, manage the memory, and we don't have to worry about any of the details. Very, very cool. Now our only major concern is once we get that populated, how do we read that back? Well, first things first, let's go ahead and populate this. That way we don't forget about it later. Now let's go ahead and read this back. And I want to say void show teachers. I'll go ahead and grab this. And I'm just going to say Q info teachers, and then we're going to for each. And we can't do teachers. We can't say like, teacher pointer, because the children in any Q object is a list of Q objects. So what we have to do here is say Q object pointer, and let's call this the ever descriptive object. And it is going to return a Q object list, which is basically just a list of pointers to Q objects. And from there, we can just simply cast it. So we're going to say teacher. And let's go Q object cast. And we're going to grab that object. Now we're using QObjectCast because they're both Q objects, so we want to make sure that this does not fail if it's the right type. You might run into some issues with some of the more traditional or the standard C++ cast. QObjectCast is designed specifically for Q objects. All right. And then we can say if we have the teacher, then simply Q info. Go ahead and print that out. Very, very simple. Now we can take the same function and apply the same thing to students. Notice how I'm handing it the school, our parent object. So we can now just simply say, if we have the teacher, then let's go ahead and do the same thing for our children. And we can just and then grab this, and it's very, very simple. Actually, I'm just going to grab both of that right up here. And I'm going to say student. And I'm going to switch this to teacher here. Very simple, very easy to understand. So really, we can say show teachers from our school, and then we're just going to grab the top level children. If we wanted to, we could say show students. We're handing it the root object, the school, and we're going to say get every teacher, and then if we have a teacher, inside each teacher, get the children, and print out the individual students. So we have a nice object hierarchy here. Very simple, very easy to use, and it just works. This is something I love about building composite objects with Qt. Takes a lot of the complexity right out of here. Save, run. And as long as we didn't mistype teacher a bunch of times, everything should work. So we've got our students, and everything's working as expected. Or is it? So we actually didn't do this show teachers. Let's do that real quick here, just to show this is working. There we go. Want to make sure we're using both of those functions or somebody's going to comment, hey, you skipped it. So we've got our top level objects, and then we can drill into the individual students. Very simple, very easy to use, easy to understand. Now, why would you use the parent-child relationship? It's easy to add any kind of QObject and then cast it back to whatever you need it. And it does the memory management for us just by adding it. Now, why wouldn't you use this approach? Why would you use the previous approach where I made this prototype? Well, for example, if you want to make some sort of interface where you're going to say, hey, this is my application's API, call getStudent to get a pointer to the student. You could still, under the hood, do something like this, but it would be a little more complex. Let's take a look at the decorator design pattern. This one is a little bit different than what we've been talking about. So the intent here is to attach additional responsibilities to an object dynamically. Now you can think of this like wrapping a gift. You're going to put it into a box, then you're going to wrap the box. So really you're kind of just putting objects and objects and objects and objects, but each object does something slightly different. It's part of an overall process. Let's take a look at an example of the decorator here. So what we're going to do is HTML tags. And if you don't know HTML, don't worry, we're not going to deep dive into HTML. I'm just going to show you how to do some basic text processing here. So first things first here, we're going to add the new, and I'm starting from scratch. We're going to say we want a text class. This of course is going to be a QObject. Once we get in here, I can say include QDebug, and I'm going to say virtual void process. So the whole point of this function here is just simply going to be to process some type of string. That's all we're going to do. Let's go ahead and add this. Now in here I'm going to say if parent. Notice how the first thing I'm doing is saying we have to have some type of parent. Then I'm going to say text QObject cast. I'm going to cast that parent, whatever it is, to, you guessed it, this class. And if we're able to cast that, then I'm going to say text process, and then we're just going to process this input. And this may look a little weird. You may be going, wait a minute, why are you doing it this way? Well, what we're going to do is we're going to make another class. And I'm going to say, let's call this, I need like a special name. Bold text, why not? I struggle with coming up with names sometimes. And inside of bold text, we are just going to inherit the class we just made, text. Grab this, make sure that we actually add that in there. If we don't like that, we could just grab it like this. Bunch of different ways you can do this. Then we're going to switch, and in here, this is where the magic really happens. I'm going to say text. So we're going to take our base class. We're going to process that input. And then I'm going to say input. And I'm going to insert at 0, the starting position. And this is where, if you don't know HTML, you may be a little bit confused. But this is the HTML tag for bolding something, or we're going to start to bold. Then I'm going to say input append at the very end, I'm going to turn off that HTML tag. That's kind of how HTML works. You turn a tag on, you turn it off. So in HTML, anything after this is bold and anything before this is bold, so the text in between. So notice the order here. I'm saying bold text, process, and then we're going to call text process our base class, which does effectively nothing. But once we actually chain these together, which we're about to do, you'll see exactly what I'm talking about here. So I'm going to make another class. Let's call this italic text. And we're going to just go bang. And what is the problem here? Direct base QObject inaccessible due to ambiguity. Maybe it's because I have one too many of those. There we go. That should fix it. Slightly embarrassing that I missed that first time around, but mistakes will be made. Let's go ahead and not make the same mistake again. And we're going to go ahead and we are going to just insert virtual function of base class. Going to add that in. Bang. If we don't like it here, we can get rid of all this formatting and put it right up here. And then we can grab our bold text, flip over to italic, and then we can just set the HTML decorator there. So if you're kind of following along here, what we're doing is bold will take the text and just encapsulate it in the HTML bold. Italic will take the text and encapsulate it inside of the HTML italic. Seems kind of weird. Why would we do something like that? Well, if we flip into our main, and I'm just going to put some includes in here, we're going to have text, bold text, and italic text, and let's just play around with this. And let's look at the decorator design pattern in action. So I'm going to say QString, and let's call this value equal text. Now I'm going to say text T, and then we're going to chain some things together. And I'm going to say new bold text, and then new italic text. Now you may be going, no, wait a minute, whoa. You just created a memory leak. You're absolutely right. We did. Realistically, memory leaks aren't that dangerous in this context because as soon as this application quits, my operating system is going to go in and free up as much memory as it can. That is not a guarantee, so we want to make sure we do actually free up that memory some way, somehow. So really all we're doing here is we're chaining these together. We have a text, which is going to hit bold and then italic. Now we're going to process that. And let's go ahead and say QInfo. And I want to take that value back. So what do you think is going to happen here? Save and run, and let's look and see. There is our outputted text. Bold, bold, italic, italic. So if you guessed it's wrapping it, you're absolutely right. So really all we're doing is we are using the decorator pattern. This is extremely flexible. You're going to see this in many variants out in the wild, and to be brutally honest, a lot of applications you use this pattern whether they realize it or not. Let's take a look at the facade design pattern. Now, this one is dead simple, but it can get really complex if you let it. But you've probably done this thousands of times. This is actually fundamental computer programming. Basically, all we're going to do is wrap a complicated subsystem with a simpler interface. Like I said, you've probably done this and not even realized it. So let's take a look at a real-world example here. We have a hotel that I own. I don't actually own a hotel, but in computer programming land, for this example, we own a hotel. Now we want to interface with this third party, so we have to adhere to their API, which is going to have the iHotel interface, which just simply says book room. However, in the real world, things are not that simple. I've got booking, they actually go get the room. I've got housekeeping that cleans the room, and I have Bob. And Bob, he just fixes things. He's my maintenance guy, but Bob is incredibly lazy, and I've got to tell him go do it like 10 times before he'll actually go do something. Anyways, the customer for the third party does not want to know any of that. They want to just say book room, and it just magically happens. So let's take a look at how to make this happen. And first things first, I'm going to hide all this complexity because we just simply don't need it. Give it a good build, make sure we haven't got any gremlins lurking. And then I'm going to say new class, and we're going to say hotel. This is going to be a Q object. And the whole point of our hotel class here is to implement that interface and hide all the complexities of booking a room. So I've got Q object, Q debug, our interface, my hotel Bob, my hotel booking, my hotel housekeeping, and each one of these has their own independent reason for existing here. From here, let's go ahead and go public iHotel. And let's implement that interface. iHotel book room. And then we want to actually implement this. This is the fun bit here. So all the outside world's going to see is book room, but we have a hotel to run. So I'm going to say booking, housekeeping, and Bob. Good old lazy Bob. Remember, Bob is our maintenance guy. So first things first, QString, I want to get a room. So I'm going to say booking. Let's go ahead and get a room. And that would be whatever subsystem we'd have, which would go through and say what room is free. And we're not going to worry about the complexity on that because we're focused on this class. Once we've got a room, then we can go ahead and say booking. And we're going to go ahead and book that room because we know it's free. And this is where, like Priceline.com and all that stuff comes in, and we lock in some rate and what little options they want and all that stuff. But there's a problem. My hotel is very old, so that's why I have Bob. Remember, Bob's lazy, so I have to tell Bob like 10 times. To go do something. And I'm going to say, lazy Bob, get off your butt and go fix it. And Bob has his own special function, fix it, and I have to tell him specifically, go fix this room, and then what to fix, the sink. Once we've encouraged Bob to actually do his job, Bob is of course messy, so now I've got to send housekeeping up there to go clean the room. Housekeeping will make it nice and neat, make everything beautiful for the customer. Because remember, the customer does not want to know any of this nonsense, but then I'm going to do whatever the API I'm working with calls for. In this case, I'm just going to QDebug out, or actually QInfo out, your room is ready. And the room number, in this case, just spit this out. Very, very simple. There is absolutely no reason to make this overly complex because the whole point of this design pattern is to take a complex subsystem and make it easier to use. So don't over-engineer this, don't reinvent the wheel. And let's go ahead and see this in action. I'm going to include our hotel and hotel, hotel, and then let's just demonstrate the book room function. Save, run, everything should work unless we goof something up. Sure enough, we're going to book room 13. Ooh, unlucky, room 13. And then we're going to say, Bob, go do it. And we got to tell Bob like 10 times. And then he goes, okay, I'm headed to room 13 to fix the sink. And then housekeeping is going to come in and clean it. And then your room is ready. So really, that's the whole point of this design pattern, is take some really messed up process and make it much easier to use. we're going to look at the flyweight pattern, and this is a little bit hard to really wrap your head around. And if you Google flyweight, it's not very helpful because there's a wrestling maneuver called the flyweight, so you can get a lot of guys punching each other down and stuff like that. But basically, a flyweight is a pulley system that makes lifting a heavier object easier. So we're going to take some sort of heavy object and share that through lighter objects. And it gets a little bit cumbersome. And if you really read through, like on SourceMaking, they do a great job of explaining it, but really it's kind of still hard to understand. So we'll say you have a client, you want to get some sort of species, which goes through a factory, which goes through billions of different types of species of insects, and then you're going to return something. That's kind of frustrating. And it can get really, really complex really fast. So we're going to deviate from that. We're going to try and make this a little bit simpler. We're going to make a coffee shop. And our heavy object here, this coffee shop, is going to have a menu of, like, let's say 1,000 items. So yeah, that's a pretty lengthy menu. We don't really want to start whipping around 1,000 items in memory here. So first things first, let's create our coffee shop. We also want to make this a little more complex because we want this to be multi-threaded. Yes, always fun. So I'm going to say order. I'm going to give that a Q object. So the premise here being the shop and the order are going to have to work in tandem with each other, but they really don't need to. When I say that, what I mean is the shop is going to do the heavy lifting, the order is just going to use whatever the shop has available. So let's go ahead and jump into our shop. We're going to use QObject, QDebug, QStringList, QThreadPool, QRandomGenerator, and our order. And we haven't really done a whole lot of static programming, but let's go ahead and do that now. So I'm going to say static void init. We're going to have a menu, and if it bugs you that that's kind of in there with the functions, we can drop it down. And then we want buy, and buy is going to be a customer number and an item number off our menu. Now, if you're wondering, well, why aren't you using like a singleton or a magic static? You absolutely can. I just felt like doing it this way to take out some complexity in case somebody skipped that day. So init, super simple. We're just going to build a menu of 1,000 items, and it's just going to put that in the bulky QStringList. Not fun. So we really don't want to copy that around because that's a lot of copying to do. Also, the other complexity here is we want this multi-threaded. So you guessed it, our order is going to be a runnable. We haven't implemented that yet. So let's go ahead and comment that out. Jump over to our order. Oh, we got some surgery to do. So first things first, let's grab some includes. QRunnable, QRandomGenerator, QDebug, QThread, and our shop. We're going to go ahead and we're going to implement the QRunnable interface. And I'm going to right-click, insert virtual functions of base class. Really super annoys me that it does that, and I'm going to actually not use a Q object for this. We're going to get rid of this right here. All right, this is officially no longer a Q object. Let's give it a build, make sure I didn't goof anything up at this point. Uh-oh. Shop menu. Yes, we have goofed already. There is our menu right there. Why are you complaining? Undefined reference to. Oh, I know why. This is why I wanted to slow way down right here. Whenever you work with statics, it gets a little bit weird. So what we need to do is go up here in our implementation. I'm going to say QStringList shop, and we need to initialize that menu. There we go. Menu equal QStringList. One of the fun things about working with static functions. Let's go ahead and give that another build just to make sure. And all right, we just have some warnings left. We can take care of those later. Flip back over to our order. This is where the fun bit happens here. So I'm going to make a custom bang. So order, let's go ahead and build this constructor out. We've got a customer and an item. Just saving a little bit of time here. All right, so in a constructor, we're just setting two private variables, the customer and the item, and then our order is going to actually do stuff. So all we're really going to do here is we're going to say starting the order for the customer, whatever that is, and then we're going to get a random number somewhere between 0 and 1,000, and then we're going to make this thread sleep for at least 1 second. Now, this comes the fun bit. We want the order to use the shop's menu. If we flip back into source making, remember they've got kind of this triangular pattern here. That's really what we're going to implement here in about 2 seconds. So let's go ahead and figure this out. So let's go back into our order. And I want to say QInfo customer, whatever our customer is. And I might space these out just a little bit so it doesn't look a little weird. Now I want to say shop, and let's go ahead and get the menu, and then it's just a string list, so I can say at and then whatever item they ordered. Pretty simple, pretty easy to use. Now let's flip back into our shop here, and buy is what we're really focused on. So in here, we're going to say order, and then we want a customer and whatever item they ordered. And this is one of the drawbacks with the flyweight pattern is there's really billions and billions of ways of doing this. So people tend to argue about this pattern. They go, oh, that's not really a flyweight pattern, that's some other pattern. And honestly, some of these patterns, especially the flyweight, start to bleed into other patterns, and it gets really, really confusing. Anyways, we're going to say QThreadPull, and we're just going to kick this thing off. It's assumed if you're taking this course, you already know what all this means. If not, I think I covered this in the Qt Core Advanced. So all we're doing is we're saying order, make a new Q runnable with our customer and our item, and then we're going to say set auto delete so I don't have to mess around with that memory, and then the ThreadPull's global instance is going to start that runnable, which of course is going to go over here and run this. It's going to put our thread to sleep for a specific amount of time, whatever that random number is, and then, hey, order up, you're good to go. Notice right off the bat, we are using that shop's menu. So we are sharing that information between these classes, and it doesn't really matter how you do it. There's really no wrong answer here. But the whole point of the flyweight pattern is you take bulky data and make it common to each object. Again, millions of different ways we could have done this. We're just showing one way. So let's go ahead and figure this out. So I'm going to say shop. We're going to make this coffee shop work because I need my coffee. I'm going to say init, and then just so we can prove here, total items, and then we want the shop menu length. There we go. Now from here, it becomes very, very simple. We can just say int count, and we're going to just make a ton of orders. So I'm going to say Q random number generator because why not? Global, and I'm going to get some random number between 0 and 1,000. And then for int customer equals 0, customer is less than whatever that count was. Then we're going to increment that. I don't know, is 1,000 people at a coffee shop a bit much? Maybe like 100, and that would be like in a big city. Can you imagine a coffee shop serving 1,000 people? That would be insane. Anyway, so we're going to say int item, and then we're just going to grab some random item off the menu. And I'm just using random pretty heavily because I don't want to really mystify any of this. I wanted to show that, hey, we are working with this shared object. It doesn't really matter how we do it. Again, we're going to say shop menu, our shared object here. length -1 because we don't want to index out of range error. And then shop, I'm going to go ahead and buy that item. So the customer, whoever that customer is going to buy whatever item they wanted. All right, let's save this, let's run this, and let's see this flyweight in action. Now I put this in a multi-threaded so you could see this kind of like coming up with different orders and different times and things like that, so it's not sequential. And there you go, it just works. So really, the whole point of the flyweight pattern is to take a bulky object, in this case, actually let me scroll up here, our 1000 item menu, and make it accessible to any customer, any order. So again, the flyweight just takes a bulky item and makes it common to each object. Different ways you can do this. This is just one example.